In this video, we're going to continue looking at the tangent function and how to graph it. We'll look at translations in the x-axis as well as reflections, finishing up looking at the different types of transformations and how these affect the graph. So to begin with, what about translations in the x-axis? So in the previous video, we looked at translations in the y-axis, that's moving up or down, but now we're looking at the translations in the x-axis, which is sort of like to the side. It's moving from side to side, and this is when you replace x with x minus k. So that means we're going to now get a function such as y equals tan x minus pi on 4. So with x, or x minus, let's say, pi on 6. So when it's x minus pi on 6, that means we have moved everything across by pi on 6. So everything has been shifted by pi on 6. So every value, every asymptote, every intercept has been shifted. So that means that before used to be 0, 0. And now this sort of starting point will be pi on 6, 0. And then you have the others. This was before x is equal to pi on 2. But now it's equal to pi on 2 plus pi on 6. And so the general form used to be pi on 2 plus the period. So the period is still pi, so this hasn't affected the period. So the period is still pi, and that means the general form was pi on 2 plus pi k. Now the general form is pi on 2 plus pi on 6, which is 4 pi on 6 or 2 pi on 3. So 2 pi on 3 plus pi k, where k is an integer. So what that basically means is we've added pi on 6 to one of them, and then every other one's going to be pi away from that, pi away, pi away. And the same thing goes with the intercepts. Now that it used to be 0, and then used to go to pi, and then 2 pi, but now it's going to go from pi on 6 to pi plus pi on 6, so 7 pi on 6, 0, etc., and it'll keep on going. One of the main differences though is that there may be now y-intercept where previously there wasn't, so you would have to calculate for this value. So that's when you let x equals 0, so you'd let x equals 0 tan negative pi on 6, and you'd get 1 on root 3, and then because it's in negative, so the fourth quadrant, that means it's going to be negative, and it works out because from this graph it's negative, so that's always good when if we got a positive answer, then there would be something wrong with the graph. So we'd have 0, negative 1 on root 3, which you could simplify to times both the numerator and the denominator by root 3 to rationalize it, and you could get root 3 on 3. So it's basically the same as before, but just remember about this minus pi on 6 when doing all your calculations, such as your asymptotes, your x-intercepts, and be careful, there could be a y-intercept, which previously there wasn't, so you should always check for that as well. So now moving on to reflections. So if we want to reflect in the x-axis, so this is like swapping everything in the x-axis or having a mirror in the x-axis, which can change everything. What we do there is we replace y with negative y. So that means our equation is now going to look at like negative y is equal to tan x. Take the negative to the side and we get y is equal to negative tan x. So if we have, there's a general graph here, then so this is a standard tan graph, and if we reflect in the x-axis, then we think, okay, we're going in the x-axis here, then this has to be reflected down. So that goes down, that has to be reflected up, that has to be reflected down, that's to be reflected up, that's to be reflected down, etc. So all you note is that the period is the same, the intercepts are the same, and the asymptotes are the same. However, obviously the values of the graph are changing, but any x-intercept will always remain an x-intercept, because if it's on the line, then it's not going to be reflected, or will remain the same value. And then with the asymptotes, as they are vertical asymptotes, they're going to be reflected in the x, and they'll have the same equation as before. So we'll have that there, there, and there. So finally, what about if we're reflecting in the y-axis, in the x-axis? So previous, sorry about that, I mean reflection in the y-axis. So we just looked at reflection in the x-axis, but now we're looking at reflection in the y-axis. So that means we have to replace x with negative x. So that means if we originally had y equals tan x, we're now going to get y is equal to tan negative x. So this is going to reflect it in the y. So previously we were looking at the x-axis and would flip it. Now we have to look in the y. So we are going to get, from this basic form, y equals tan negative x, it will look like the previous one we calculated. So it will look like this, the green. However, you do have to be careful because once more transformations are applied, then this may not necessarily be the case. So it's important when you reflect in the y-axis that obviously the y-intercepts will stay the same, and then the x-axis intercepts may change depending on where they are. So if they're, for example, at -1, 0, then -2, 0, -3, and then this one's 1, 0, 2, 0, then when they're reflecting the y, they're going to get the same because of the same distance. However, this won't be the case if you have values such as here, which is, let's say, a -0.5, 0, and then the next one over here is 2, 0. Because when that reflects, that's going to reflect in the y-axis to -2, 0, and that's going to reflect over here to +0.5, 0. So what I mean by this is that look at the graph and then you can see this, but the easiest way I find with reflection in the y-axis is that just make sure you remember there's a negative x here. When you calculate the x-intercepts, when you calculate the asymptotes, as long as you remember there's a negative x and then you make the values negative, then you'll get the right graph. So if you do this before you graph it, so if you calculate the asymptotes as well as x-intercepts before you graph it, as well as looking at the starting points and the y-axis and what shape it looks like, then you won't have any trouble. Main thing is to do these before, make sure you have the negative x so you can take negative to the other side, and then the reflection in the y-axis will be pretty simple.